The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to start looking at section 10.4. We'll also be covering section 10.4 tomorrow, as well as the chapter review. And all of this is due no later than Friday. Okay, so today's assignment, tomorrow's assignments are all due by Friday at 11:59 p.m. Friday we'll be reviewing for the chapter 10 test, which will be on Monday. All righty, so what I want to do now is I'm going to change screens. So I'm going to pause the recording. All right, we'll continue the recording now. And we have the graphing screen. So let's take a look here. We have the equation, which is also a function, f of x equals x squared. We're going to graph this. We've got a table there. We'll find some values and plug them in and form the graph. So first of all, let's find, now let's make sure this is going to work. First of all, let's find f, it's going to do that to me. Give me just a second here. Okay. Here we go. F of -3 is -3, the quantity squared, which is 9. F of -2 is -2, the quantity squared, which is 4. F of -1 is -1, the quantity squared, which is 1. F of 0 is 0, the quantity squared, which is 0. F of 1 is 1, the quantity squared, which is 1. F of 2 is 2, the quantity squared, which is 4. And f of 3 is 3, the quantity squared, which is 9. So plotting those points, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9, we get this shape. Now, it doesn't look like it's a straight line, does it? Let's see here. And graph this. Finish that up. What we get is called a parabola. Okay, and it's not a linear equation, it's a second degree equation. And this parabola, notice if we look at the table, there are some repeated y values. And what that causes, if we look at our graph is symmetric about a line, which in this case is the y-axis. And this is called the axis of symmetry. Okay, so the parabola is symmetric about this axis of symmetry. When a parabola opens upward, which is how we describe this, this lowest value is called the vertex, which in this case is at 0, 0. We'll also have parabolas that open downward, and their vertex will be at the top of the graph. Okay, now let's go on to the next page. Here we already have that same graph formed, f of x equals x squared. But now we're going to take a look at f of x equals x squared plus 3. And let's see what happens when we calculate those values. So f of -3 is going to be -3 squared plus 3, which is 9 plus 3, which is 12. So notice the first part was just like f of x equals x squared, but then we added 3 because of this term. All right, f of -2 would be -2 squared plus 3, which is 4 plus 3, which is 7. So again, That first part matches the previous, the black equation, and then the +3 adds 3 to the y value. F of -1 is -1 squared plus 3, which is 1 plus 3, which is 4. So all of these values are just these values increased by 3. So this is going to be 3, 4, 7, and 12 likewise. Okay, and what is that graph going to look like? Well, when x is -3, y is 12. When x is -2, y is 7. When x is -1, y is 4. 0, 3, 1, 4, 2, 7, 3, 12. And let's see what we get. And graphing that further. We get a picture, well, almost got it there, comes down a little further. It's the same shape as f of x equals x squared. So the red graph is the same shape as the black graph, but what has happened? The red graph has moved up 3 units. So by adding a constant term outside of the x squared term, we cause a vertical shift. A +3 moves it 3 units up. All right, let's go to the next graph. Here again, we have f of x equals x squared, but now we're going to graph f of x equals x squared minus 4. Let's see what's going to happen there. So f of -3 is going to be -3 squared minus 4, which is 9 minus 4, which is 5. F of -2 is going to be -2 squared minus 4, which is 4 minus 4, which is 0. F of -1 is going to be -1, the quantity squared, minus 4, which is 1 minus 4, which is -3. Well, again, this first part is just like the f of x equals x squared. But what do we do once we get x squared? We subtract 4. So these values are 4 less than those values. 9 minus 4 is 5. 4 minus 4 is 0. 1 minus 4 is -3. 0 minus 4 is -4. 1 minus 4 is -3. 2 minus 4, let's see here. 2 minus 4 is 0, or 4, excuse me, 4 minus 4 is 0. And then 9 minus 4 is 5. I confused myself there. Doesn't take much. All right, let's plot those points. -3, 5, -2, 0, -1, -3, 0, -4, 1, -3, 2, 0, and 3, 5. Okay, let's see what we get here. Okay. Again, the red graph is the same shape as the black graph, except now what's happened? This -4 outside of the x squared term has caused a vertical shift downward. So if we have y equals x squared, if we add a number outside, it moves it up that far. If we subtract a number outside, it moves it down that far. Okay, let's go to the next graph. Now we're going to go and put a number inside of the x squared. So it's no longer a constant outside, but it's inside. And let's see what's going on here. Okay, now, if I just use the same x values as before, as in these, let's see what happens, okay, for this one. If x is -3, we'd get f of -3 equals -3 minus 2 squared, which is -5 squared, which is 25. Is that right? Let's see, -3 minus 2 is -5, 25. Yeah, that's right. All right, -2 f of -2 would be -2 minus 2 squared, which is -4 squared, which is 16. F of -1 is -1 minus 2, the quantity squared, which is -3 squared, which is 9. F of 0 is 0 minus 2 squared, which is -2 squared, which is 4. F of 1 is 1 minus 2 squared, which is -1, the quantity squared, which is 1. And f of 2 is 2 minus 2 squared, which is 0 squared, which is 0. And f of 3 is 3 minus 2 squared, which is 1 squared, which is 1. Look at what's going on here. These values are the same as those values, but things have shifted. Here we had a -3, here we have a -1. So in fact, on this table to the right, we'd get that, wouldn't we? Well, it just seems like this would be a 4 and a 5. So what's happened here? All of these x values, to get the same y values as before, the x values are 2 greater. This plus 2 equals that. This plus 2 equals that. This plus 2 equals that. Why is that? Well, inside of the square, we put x in, then we subtract 2 and square the results. Well, we need our x values to be 2 larger than they were before, because the first thing we're going to do is take 2 away from it. Now, what does all that do to our graph? Well, we've got this big mess here. Let's see if I can erase some of this and make it easier to look at the graph. I know this is exciting watching me erase things. All right, now, what's that going to look like? When x is -1, y is 9. When x is 0, y is 4. When x is 1, y is 1. When x is 2, y is 0. When x is 3, y is 1. When x is 4, y is 4. And when x is 5, y is 9. Okay, let's see what that thing looks like. Got this upside down. Okay, and here. Well, once again, the red graph is the same shape as the black graph, except what's happened? It's moved 2 units to the right. Now, if we go back, let's see here. When we added a +3 outside on the graph, it moved it up 3. When we added a -4 outside of the x squared part of the graph, it moved it down. But now a -2 inside moves it 2 units in a plus direction to the right. So what do you think is going to happen here with an x +4? Well, let's see, a -2 moved it to the right, so +4 should move it to the left 4 units. Let's do it this way. Let's plot the points and then see if that, in fact, gives us the right ordered pairs. If it's going to move 4 to the left, let's see, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 4. So I'm predicting that that is where our graph is going to be. So let's forget about this and let's look at this thing here. Let's see. It looks like 1, 2, 3, 4, 5, 6, 7. So negative 7, 9. Is that correct? F of negative 7 equals negative 7 plus 4 squared, which is negative 3, the quantity squared, which is 9. Bingo. All right, let's see. Negative 6, 4. Let's see if that's true. F of negative 6 plus 4. Negative 2, the quantity squared is 4. Bingo, etc., etc. Okay. Negative 5, negative 4, negative 3, negative 2, and negative 1. So inside, it moves it the inverse. Outside, it moves it the obvious. Let's go back here again. A plus 3 outside moved it up 3. A minus 4 outside moved it down 4. A minus 2 inside moved it plus 2 to the right. And a plus 4 inside moved it minus 4 to the left. All righty. Now, let's see what else we've got here. Oh, let's put a negative sign in front of the x squared. Now, keep in mind that negative sign right here is not part of the base. It's x squared. It's not negative x squared. If it was going to be negative x squared, we'd have to write it like that. Okay? So f of negative 3 is going to be negative times negative 3 squared, which is negative times 9, or negative 9. F of negative 2 is going to be negative times negative 2 squared, which is negative times 4, or negative 4. Well, can you see what's happening? It's just going to negate all of the y values. Well, then where would that be? Well, let's see, negative 3, negative 9, negative 2, negative 4, negative 1, 0, 0, 1, negative 1, 2, negative 4, and 3, negative 9. So we get the same shape, only now, let's see here, it is flipped upside down. Okay. So having a negative out in front of that x squared flips the graph over. Okay. And let's see here. Where did my mouse go? There it is. What about this? What if we put a coefficient in front of x rather than just a positive one or a negative one? What does the 2 do? Well, f of negative 3 is going to be 2 times negative 3 squared, which is 2 times 9, which is 18. F of negative 2 is going to be 2 times negative 2 squared, which is 2 times 4, which is 8. F of negative 1 is going to be 2 times negative 1 squared, which is 2 times 1, which is 2. What's happening? Well, we've got x squared. We do that first. That's just like the black equation, but then we're going to multiply it by 2. So all our y values will be twice what the y values were before. Well, let's see, negative 3, 18. I can't get that on this graph. It goes beyond the page. Negative 2, 8 is right there. Negative 1, 2, 0, 0, 1, 2, 2, 8. Let's see here. Let's just do this freehand. And it's going to come out like that. So now the shape has changed, hasn't it? It's gotten narrower and taller, okay? Because again, this y value is half of that y value. This y value is half of that y value. The red y values are double the black y values, okay? All right, now, let's see here. I think that's the last one I had. Oh, wait, what about 1/2 x squared? What's that going to do? Well, f of negative 3 is going to be 1/2 times negative 3 squared, which is going to be 1/2 times 9, or 9/2. It's going to cut this in half. So 2, 1/2, 0, 1/2, 2, 9/2. 9/2 is the same thing as 4.5. So negative 3, 4.5, negative 2, 2, negative 1/2, 0, 0, 1/2, 2, 2, 3, like that. Okay, what does this graph look like? It's opening up wider. So let's go back and kind of review what's going on here. Okay. The black equation is a parabola f of x or y equals x squared. If we add a 3 constant outside the x squared, it moves it up 3. If we subtract a 4 constant outside, it moves it down 4. If we put a -2 on the inside, it moves it to the right 2. A +4 on the inside moves it to, oh, I never finished graphing this. It moves it to the left 4. Sorry about that. And if we put a negative coefficient in front of the x squared, it flips it over, makes the y values negative. If we make the coefficient of x squared larger than 1, it makes it climb faster, and between 0 and 1 makes it climb slower. All right, so let's sum up all of this. If we have the following, y equals a times x minus h squared plus k. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downwards. Okay, now there's something else I want to look at. Let's go back here again. Where is the vertex for f of x equals x squared? It's right there. Okay, it's at 0, 0. So where is the vertex for x squared plus 3? It goes up 3. So this one is at 0, 0. This one is at 0, 3. Okay. This one is, again, I'm just talking about the vertex. This one is at 0, 0. This one is at 0, negative 4. Here, the vertex went from 0, 0 to what? 2, 0. And then here, it went from 0, 0 to negative 4, 0. Here it stayed at 0, 0, and here it stayed at 0, 0. Okay. So what we've got is this. The thing called the axis of symmetry, which is a dotted line that goes through the vertex. It's a vertical line about which the graph is symmetric, is going to be at x equals h. Okay, it's an equation. It's not just a value. It's at x equals h. The vertex is at h k. All right. Now, what do I mean by that? We're going to go to Webassign, look at some problems. So I'm going to pause. All right, we're going to start the recording back up again. And here we are in Webassign. Oh, you know what? I thought of something else I want to do. Hang on. All right, so we've got Webassign, and we've got a whiteboard I can write on. So hopefully this is coming out all right. All right, let's take a look at this problem over on the left. Problem number 12. It says, find the vertex and the axis of symmetry of the graph of the function. Okay, and the function is f of x equals the quantity x minus 1 squared plus 9. If we compare that to the form y equals a times x minus h squared plus k, we see that a is equal to 1. So a is greater than 0, which means the parabola is going to open upwards. Okay, so over here, do not graph the equation, but determine whether the graph will open upward or downward. It's going to open upwards. Okay, now the axis, the axis of symmetry is at x equals h. In this case, h is 1. In fact, h is 1 and k is 9. So it's going to be at x equals 1. So over here, I can't just put in 1. I've got to put in x equals 1. So that's that dotted line or dashed line, vertical line that goes through the graph that shows the symmetry. The vertex is at hk. So the vertex would be at 1, 9. So back here, 1, 9. And let's see what it says. All right. So the axis of symmetry is at x equals h, which is the 1. The vertex is at hk, so 1, 9. Because a is positive, this thing opens upwards. Let's take a look at another example. This is number 13. Okay, let's see. Let's go back to black here and see how that looks. All right. So we've got f of x equals -4 times the quantity x plus 3 squared minus 4. Let's just do this. A is -4, right? And h is -3 and b is -4. Keep in mind, if we think of it as y equals a times x minus h squared plus k, x plus 3 would be x minus -3. So outside it's what's obvious, and inside it's the inverse of what's there. All right. So let's see. This thing opens downward because a is less than 0. Okay. The axis of symmetry is at x equals -3. So again, we've got to write it as an equation. X equals -3. The vertex is going to be at -3, comma, let's see, hk. So, oops. The vertex is at h, oops, too many whoopses, hk. So -3, comma, -4. And let's see what that says. All right, now let's talk about graphing parabolas. Let's take a look at this one, okay? It says determine the vertex and the axis of symmetry of the graph of a function. So get the vertex, the axis of symmetry, and then graph it. Okay. So we've got f of x equals x minus 3 squared plus 9. So a is 1, h is 3, and k is 9. I almost wrote b is 3, and that's not b. Okay, so a equals 1 is positive, so this thing is going to open upwards. They don't specifically ask us that, but that's still okay. The axis of symmetry is at x equals 3, x equals h. The vertex is at h, k. All right. So the axis of symmetry is at x equals 3. The vertex is at 3, 9. Okay. All right. Now we're going to graph this thing. And here's how we have to graph a parabola in Webassign. Okay. Let me backtrack a little bit. Back before, when I had all those graphs on the screen and I found a bunch of different points so that I could draw the whole picture. Okay. But to do it in Webassign, you only need 2 points to graph a parabola. You need the vertex and another point on the graph that is not the vertex. But you must graph them in this order. You must graph the vertex first and then a second point. All right, so in the graph here, we're going to click on the parabola button till it turns blue. I'm going to start with the vertex, which is at 3, 9. Now be careful because this graph, the scale, each square is 2 units. So 3, 9 is right about there. Okay. Now, I need to find another point. Let's pick a point that's to the right or to the left. How about 4? If x is 4, what do we get? F of 4 equals the quantity 4 minus 3 squared plus 9, which is 1 squared plus 9, which is 1 plus 9, which is 10. So 410 is my second point. All right, now, as with graphing linear equations, we can come over here and we can look and see if we've got our points graphed correctly. 3, 9, 4, 10, we're good to go. So submit answer, and it says everything is correct. I want to go back and I want to do it wrong to show you why you've got to do it correctly. I'm going to plot those same 2 points again, but I'm going to do them in backwards order. 4, 10, and then 3, 9. See, it thinks that 4, 10 is the vertex, so that means it has to open away from it, and this is incorrect. Okay, let's see what it says. Yeah, so you've got to graph the vertex first. Okay, let's see here. I wanted to find one that had fractions. Let's do this one. Okay. Yeah, we still got time. Okay, so f of x equals 1/8 times the quantity x plus 1 squared minus 3. Okay, a is 1/8, which means this parabola opens upwards. H is -1 and k is -3. So the axis of symmetry is at x equals -1, and the vertex is at -1, -3. Again, I can't overemphasize how much people constantly mess this up. They don't write the axis of symmetry as an equation. They just put in -1 and then they wonder why it's wrong. It's got to be an equation. X equals -1. The vertex is at -1, space -3. Okay, now, so -1, -3 is right there. I need a second point. Okay. Oops, it's not quite where I wanted that line, but that's okay. We'll put it down here to make more room for it. Let's go with 0. Okay, let's put 0 there, because that's right close to the -1. You want to pick values close to the vertex. So f of 0 is 1/8 times the quantity 0 plus 1 squared minus 3, which is 1/8 times 1 squared minus 3, which is 1/8 times 1 minus 3, which is 1/8 minus 3, which is 1/8 minus 24/8. Now, what did I just do? I wanted to combine the 1/8 minus 3, so I needed a common denominator of an 8. So I multiplied minus 3 over 1 by 8 over 8, and I get 1/8 minus 24/8, which is -23/8. Now, I chose this one hoping to have horrible numbers to show you again how you can correct this. So my second point is at 0, -23/8. Well, -23/8, -24/8 would be -3, right? So it's going to be right there above it. But now, as we found with linear equations, the points tend to slide to the nice numbers. So I'm going to go back here, and there's my vertex at -1, -3. but I'm going to go in and change the y value to -23/8. Okay. And there you have it. All right. So to wrap this up, you've got, let's see here, this form, y equals a times x minus h squared plus k. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. The axis of symmetry is x equals h, and the vertex is hk. When you're plotting it in Webassign, plot the vertex, then another point. Whoops, point. All right. That's all I have for you today. Tomorrow, we'll wrap up this section. We'll look at a different way of graphing parabolas, as well as some applications using maximum and minimum values, which we'll talk about tomorrow. So let's see here. I'll stop the recording. Have a great day. I'll be back at 1:15 if you have any questions.